Hello everyone, good evening. So please open your MATLAB and open this file. I already sent by WeChat, right? Yeah. So you need to unzip first. Then you just copy the path. Then you paste it here.
Where to paste? Where? Paste to where?
Here.
Just a path. Okay.
Yeah. So if you don't have laptop, this is not a training. You should bring your laptop. Sorry? Okay. That's up to you. Huh? Okay. Mm-hmm. Okay, so we are here, right? First we open the data. Like tonight I will show you how to plot, right, in MATLAB. But maybe the next class I will show the special plot. Like today is a two-dimensional plot. Yeah, plot can be a two-dimensional, but this is like line or bar or like a histogram. This is the temporal plot, but not the special like with lat and long, right? Maybe the last class. Okay, so these are data. Before you open this data, please open here. In my every class, I say, know your data, know your data, know your data, right? So this is the data, and the first row is showing the year. That means the data from 1980 to 2017, okay? Then the first 12 row, this is the monthly data. The first 12 row is, so if it is the first row, the year, so first row, year. We need to do index, right?
Okay.
Then from 2nd to 13, every variable has 12 months. Like it's a monthly data from 1980 to 2017, right? So if it is a 12, if the first row is a year, so it should be 2 to 13, isn't it?
Yeah.
So this is the maximum temperature. It can be any data. It depends on your field. Data is not a big deal. Big deal to understand, right? Okay. Then, okay, 14 to it's 25, right? Or 26? Yeah.
26.
12, huh? Yeah.
Okay.
Then minimum temperature. Then 26 to 37 is rainfall. Three variables, right? 12 is 36, but first row is year, that's why it's 37. Did you get it now? 3 variables.
Okay.
Every variable is 12 months, so it should be 36 rows, right? But why 37? Because the first row is a year. Even in MATLAB is one base indexing, so it should start from 1. It's not Python 0 base, right? It's not like other languages, right? Even in NCL 0 base. So this is a MATLAB. It's just following the C. Okay, so we know our data, right? Now I will use this index. If I want to index like extract the data, access the data, maximum temperature, I should write row 2 to 13, right? Maybe you have in my last class, right? The index was like that. It should be row, then column, right? Always the row and column. Data, that means this is a matrix. Matrix is row and column.
Yeah.
We don't care about the data. Okay, this data from my field, but in computer science, in data science, we don't care about the data. We just care about the data. We don't care the fields of data, right? It can be any data, but we care about the matrix. Okay? So matrix is row and column. So now here, this is the function. If we want to read the Excel file, this is an Excel sheet. Like this is the first class I said, maybe Brother Birhano showed you the import and export, right? How to import like Excel file. It can be a text file, it can be a CSV file. It's not a big deal. You can search, you will find this file. But the Excel read file, then I said in the previous class, in MATLAB, it should be fast quotation. It's not Python. You can use 1, 2, 3, whatever. It will be a string or read anything, right? But this is a MATLAB. So it's following, even in C is double quotation, but MATLAB follow on a single quotation. Be careful. If you write like a string should be also the single quotation. Even if you want to read the data, it should be single quotation. Okay? And be careful about this extension. Some Excel files has XLXS. Some files has like XLS. Right? So before you, okay, there is a one technique. Like you don't need to use manually, right? What I said, just top of the caps lock, there is a tab option in keyboard, right? So you just write like 3 words, then type tab. You don't need to type. That's why you always use tab. Even in Linux, in terminal, we always type, okay, 2 or 3 like words, the letter, then you just type, then it will come, right? You don't have to type. Maybe sometime you will make mistake. So, in programming, like if you make mistake 1 comma, the code will not run. Even the entire code will not run. That is a problem, right? This is a machine. So now, open the Excel file. I define as data. Yeah. So it's saying, see the data structure, the matrix. 37 into the data. 37 into 38, right? That means we have 3 variables, right?
Yes.
So every variable is 12 months. So 36, but first row is year. So the row is 37, right? And the year from 1980 to 2017. So 38 years. In a MATLAB doesn't care about what the 1980. It just care about the row and column. Even any programming language don't care about the year. You need to know the which is year, right? In programming, I only care about row and column. So this is a matrix, okay? And data type is double, okay? So now, if I want to extract rainfall, what I said here, it should be 26 to 37. We have 3 variables, and every variable is like 12 months, right? So 36 by 37. So we want to extract the rainfall. If we want to extract the rainfall, so what I said in indexing, it should be row and column. So row is, you see the 26 from 26 to 37. In MATLAB, we use a column. Like from here to here, right? Column. So 26 to 37, then comma, the column means we want to take the whole years, like 38 years. You want to take the whole years, right? That's why it says just clone.
And if we are taking a smaller pair,
That's up to you. You just choose row and column. MATLAB doesn't know anything. Just care about the data. Okay. Sorry. Now, our aim to, I want to analyze seasonal rainfall. Like March, April, May. We have the 12th month, but I want to take March, April, and May, right? This is the purpose. So if I want to analyze like this, first I need to extract the rainfall, because there are 3 variables, right? The first step to extract who is variable to analyze, right? Okay, so I'm extracting the rainfall. So run this rainfall. So why, I know many of you have the programming basics, right? So why I use the data here? Like this is a structure index, but why I use the data? Oh, Shama. Why? Yeah, from where do you want to extract? I already defined data. It can be defined by your name. Like the computer doesn't know anything. You need to define. That's why it should be in the first class of what is the variable. We define the variable as a data. So if I want to extract the rainfall, so rainfall should come from the data file, isn't it? So this is your data. Then you use the index. Okay? From data. Now, I have the rainfall. If I want to access March, April, May, then I should extract from rainfall data. One by one. From where do you want to? I want to extract from the rainfall. It has 12. So that's why here I took the whole row. Okay? But 3 to 5. Why? March, April, and May. We have 12-month data. Sorry. No.
But you have taken entire.
No. Wait. I made mistake here. Oh, no. Yeah. Okay. Maybe there is a problem. Why? Yeah, okay. Why it is showing this? Can you see the apostrophe? Do you know the use of apostrophe in MATLAB? Okay, let me delete first. Why is showing like this? It's saying, no, you made mistake. No, I didn't make mistake. I transpose. Do you know the transpose? The apostrophe means transpose. So that, at the same time, I took the March, April, May and transpose. That's why it's showing like this. Okay, let me delete first. Okay? Then you see. Okay? That's why it's showing like this. Hema. Now transpose. Row into column, column into row. No. Yeah, for 38 years, then I extract only March, April, May. One by one. Like here. You see here. "38 years, isn't it? So from the data, we took only rainfall, isn't it? Then from the rainfall, I took the whole row. No, whole row.
Whole row.
Yeah.
Okay, whole row of selected column.
Yeah.
Selected mark.
So now I want to sum. What I said in nan sum. Nan sum means sometimes I don't know in my data I don't have missing value. But in your data may have the missing value. So it's better to use nan. So if you have the missing value, then MATLAB by default, this is a built-in function, will understand you have the missing value and the missing value will not be counted. Okay? So run. Total rainfall. So now, if I want to plot the line plot, you just type plot, means line plot, right? Then, what do you want to plot? Okay. Then this is the color and marker. Line and marker. Okay, let me show you. Just search here. Plot. 2D plot, two-dimensional plot. Just search here. I scroll down. Here. There is a line style. Dash, dashed line. I use here dashed line. Okay. This is a line style. Then you have the marker. You can use different marker here, from here. It's your choice. Then there is a color. But only different is blue and black. Do you know why? Only the difference is blue and black. B is blue, but K is black. In MATLAB, the difference is like B is equal blue. If you just write B, the MATLAB will understand you want to use the color blue. But if you want to use black color, you should write K. These are different, right? So these are line style, marker, and color. That's why I use the green color, the line style dashed line, then the marker is circle. Okay? Then there is also option you can give the line width, the depth of the line. Okay? So this is a line plot. This is a line plot. I'm coming one by one. How to customize and make a beautiful figure and how to export as a journal requirement like 300 dpi. If you send your paper in journal, they will ask you your figure should be 300 dpi. Dpi means dot per inch, right? So I will show you one by one how to customize the figure and how to export as 300 dpi. So this is a line plot. Okay, we have the 12.12 marker and this is a line. These are data. You can label X label, Y label, title, I'm coming. Then maybe you want to draw a vertical bar, right? Just type bar. It will give you the vertical bar. But if you want the horizontal, should be bar S. is the horizontal, that one is the vertical. What is? Okay. Then maybe you want to draw a continuous area plot. Right? Maybe you want to draw a stream plot. Plotting is not a big deal. The big deal is data analysis. Customize your data and play with the data. Then plotting is not a big deal. Just search in Google, you will find, okay, just set your data with this plot function, this function, it will give you. But, we use the shampoo. But shampoo is the final product. You should, you have the raw product, then from the field, you need to, check your product and, give to the factory, then factory will do something, they refine, etc., etc. Finally, you will get the shampoo, right? If plotting is the final product. It's very simple. But playing with data is a loud one. Now, sometimes we want to draw the pie chart, right? You can customize, but these are pie chart. Now, if you want to give X label, then Y label, and the title, maybe you want to give the legend, right? So, what I said, everything should be within first quotation, only one single quotation. It should be as a string, okay? Just type X label, these are built-in function. Then Y label, the title, the legend. Okay? But it should be single quotation. Month, rainfall, title, right? The legend. Okay, there is a question. You want to set like January, February, March, April, May, right? I'm coming. Is okay now? Now, how can we customize and export as 300 dpi figures? Like in Jalal, minimum requirement is 300 dpi, dot per inch. Just we can see the image, but image is like dot, 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 dot. That's why it's called the dpi, dots per inch, right? So if we want to customize, there is option edit. Then figure properties. Now there is option. Just click on it, you can change everything from here. X, you can change here. Y, you can change. Z, then font, you can change everything. Even the color, even the line. You see the line, you can give anything. Even there is option, see? Then I gave the green, right? Even you can change from there. So I don't recommend to do like this. Write a command, like code, and run. You don't need to do by one on one. No, it's time consuming. That's why I have written the code. You just run code. That's it. Just what you need to do. Just you need to export now. Kaima. If you want to export as a 300 dpi, then there is option in file. Then export setup. Can you see here resolution? DPI. So you need to select here 300 or 600. 300 is the basic. Then apply to figure. You see now figure has changed. Okay, the white background. Then you want to export. So there is a two option here. like if you don't save as a MATLAB figure, you have to run the code every time. You have to come here and you need to change every time. But I don't want to run the code and don't want to change. Like what I change, I want to save as a MATLAB file. In the next time, in future, I don't like, you have some comments from reviewers. You need to change something in your figures, right? Then, if you save as a MATLAB figure, then you just click on MATLAB. Just open the MATLAB and click on the MATLAB figure. It will come out the figures, not the comma. Like what you changed last time, it will be saved. So you just change a little bit and save. Did you get it? So you don't need to do by yourself again and again. It's time consuming. Okay? So that's why first I want to save as a MATLAB figure .fig. Okay? You can give any title. Save. But now I want to export as PNG file. Okay? So click on export and there is an option here. You see, even you can export as a PDF file. There is a lot of options. But we often use PNG file. So even there is option for EPS file, like if you want to modify in Adobe Illustrator, etc. So it's up to you, but we often use the PNG. Yeah, here. There is a PNG file. Then okay. And you see, yeah. Figure is there. Okay. Okay, now there is a question. I'm coming. So if you now is a one plot, but if you want to make a panel, you know the panel plot, like in one page there will be 12 or 5 together. This is called the panel plot, but in MATLAB it's called the subplot. Even in Python also the subplot, the same thing. Okay. Even in graphs it's called the bar plot. The same idea. Just you want to make some. So here it is just search the subplot. The example will be there. Now you want to make, but what is the idea? Idea is here. It's saying subplot M and P. If you, how to zoom? Oh, okay, right? The idea is here. If you understand this line, there is an example. I will tell you the structure. Then you just follow the example. What I said, everything is row and column. Isn't it? Yeah. Row and column. So, say for example, this is your printing page. When to print the image, right, or figure. Imagine this is a page, one page, right? Isn't it? The figure is one page. So this is a row, isn't it? This is a column, right? So what is the matrix? Like, I want to plot 4 figures together. Just imagine this is a one page. I want to plot 4 figures together, right? So what is the matrix now? 2 into 2, isn't it? Yeah. This understanding. Somebody came here, I don't want to mention the name, just want to get the code and go, no, you are the loser. You have to understand. You will find the code even in Google. but you need to understand. Understanding is the key. But maybe next time I will not help you to play with your data. You have to analyze by yourself, right? That's why understanding is the key. In every language, this is the idea. The matrix, row into column. So if I want to make 4 figures, there is the option 2 into 2, or maybe 4 into 1. Like there is a possibility. These are matrix. Maybe the 4 column, 1 column, right? 4 row, 1 column, right? There is option. It's up to you. So if I want to plot 2 into 2, that means this is the n, 2. See here the structure. First is m, right? This is a row. Then column, n, right? Then every figure has the position, isn't it? If the first figure, the position is 1. The second figure, position 2. Third figure, position 3. This is the 4, isn't it? That's why it's saying 2 into 2, then 1. That means you want to plot the first figure. Then the second, then third, then fourth. Idea is clear? It's clear? Yes. Now, see the example. Two into 1. That means 2 row, 1 column, isn't it? But the first figure, the position is 1. The second figure, position 2, isn't it? Clear? Am I clear? Có quên thì mà? 没有没有. Oh. Okay. Now, in the schedule, there is option anomaly, right? By brother Birhan. There is a content, and tonight contents there is like plotting something and regression anomaly, right? So that's why I'm coming one by one. So what is the anomaly? Do you know the anomaly? Yeah. What about any data? Like, if we have the data, say for example, I have the maximum temperature, right? Maybe, say for example, if it's December, maybe 12 degrees centigrade, or sometime in Nanjing in negative, sometimes, right, in the winter, isn't it? Say for example, 2 degrees centigrade. If you think about June, May, June, maybe in my country, 36 degrees centigrade. Just imagine, December or maybe then in winter month, 2 degrees centigrade, there is 36. So I have maybe the daily data or monthly data, whatever. So some day or some month has lowest temperature, right? And some has the peak, right? So there is a large difference, isn't it? So if we plot the data, we can't see anything. The extreme value can influence the lowest value, right? That's why we do the anomaly. In statistics, it is called the departure. The deviation, departure. In statistics, in metrology, we call the anomaly, but in statistics, it is called the departure. Do you know the normalized data? Normalization or standardized, right? This is also the statistics. So one part came from the normalization. Is the normalized the simple thing? So that's why we have the maximum temperature. So we have the data. Okay? Then we have the mean data. So anomaly or departure is equal, you have the real data, right? Then you subtract the mean data. Then you can see the fluctuation. It will be positive and negative. Positive means like the increase in trend. Negative means right? So now we can see. This is a departure or anomaly. In statistics, it's called the departure. That's why it's not just coding. You need to have the academic knowledge. So this is called the departure or anomaly. It can be any data, any field of data. Then you just subtract the mean value. So it will now, if there is 36 even 2, the extreme value can't influence this large value. You will see the difference, right? Then I'm coming the normalization of the why do we need to do the standardization. But there is a question. But for this purpose is fine. We want to see just the departure or anomaly. We want to just see the differences, right? Now, I already said this line. See the example. Now just I want to calculate the anomaly. I have the total rainfall, then I subtract the mean value. This is a departure or anomaly. Okay? Just run. You see the results now positive and negative. The total rainfall, the positive and negative. Now we can see there is like, this is called the centralization of the data. Do you know that what is a centralization? If you have the statistics class, and the teacher will say like the centralization of data. You see the 0 is the middle. In any data, 0 will be in the middle, so only the positive and negative value. Now you can compare the fluctuation. Right? You can see the variation. It also calls the variance analysis in statistics. You can see the variation, right? Okay, now what I said, here we have the 12th month, right? But instead of 1 to 12, we want to show as a here January, February, March, April, May, June, July, like this, right? Till December. But how can we do, right? Now I'm coming here. So in MATLAB, there is an option like built-in function. If we want to set something in x and y axis, we should use GCA. This is a built-in function. Okay? So now there is idea. What was our why I put here x tick? This is a x tick. This is x and y, right? There is a tick. Can you see? So there is like 1 to 12 because the 12-month data. So this is the x tick, right? 1 should be January, right? 2 should be February. 3 should be like you want to add a string. But MATLAB doesn't know anything. MATLAB only know there is 12 point, 12 x tick. MATLAB doesn't know anything. So you need to understand, you need to like first read the MATLAB. I want to set here is 1 it should be January and 12 should be February. December. 2 should be February, right? But MATLAB doesn't know. That's why we said here GCA x tick is 1 to 12. Like starting from 1 ending 12. This also indexes, but 1, 2, 3, 4, 5. This is a step. Did you get it? You can make 5 step also. If you have the yearly data like 5 years, 5 years, 5 years, then it's fine. This is a step. The starting point 1, ending point is 12. We have the 12 point data like January to December, right? Then what is the step? 1. Because we want to set the every x tick like January, February, March, April, May, June, like till December, right? That's why it's 1 colon 1 then 12. Then what will be here? We use the curly bracket. Means you want to make a cell array. Cell array. The curly bracket will make the cell array and you need to define here January, February, March, whatever you want. Then the structure should be within curly bracket. Then In MATLAB should be single quotation, right? Whatever you want. Even there should be semicolon, semicolon, semicolon. If you have the data point 12, it should be 12. Like if you have 30 years data, then you said the step should be 5. Then you need to know how many points should be there. Be careful, it should be consistent. Okay? Then you finish, you said that, okay, set GCA X tick label as a X label. What I said, now MATLAB will do for you. I said 1 should be January, and MATLAB will do for me. That's why I said here. Now run. Okay? Any question? This is just understanding. Okay. I didn't describe one line, sorry. Here I said X limit. Last time there was 0. Can you remember? 0 to 12. In X tick there was 0. In here. Can you remember? There was 0. Then 12. I said no. You just fixed with 1 to 12. You can set the limit. By default MATLAB will do anything. But you need to set. Right? That's why I said no. Don't put 0 here. Just 1 to 12. That's why I said X limit 1 to 12. If you have 30 points, you just fixed 1 to 12. Now it's there. Okay. This is a line. Even there is also option for Y limit. It's not a big deal. Okay. Any question? Or have a break? Any question? Yeah. Okay, let's have a break. So, there is a question. In statistics, right? Why do we need to standardize our data? What is the idea? Please share your ideas. It can be right or wrong, whatever. Why do we need to standardize our data or normalize our data? As I said the anomaly, but there is a question. What is the question? I will not tell you now. I want to get the ideas fast. Why any data is any field, right? Why do we need to standardize our data or normalize our data? Why? What? Any ideas? Okay. Just think two data. One is rainfall. The unit is millimeter. Think about maximum temperature. The unit is degree centigrade. But you want to play with these two different data sets. But statistics says you should convert it to normalize or standardize. Why? I don't care about the fields of the study. I care about the data. Why? What are the statistics now? I think we had the class of statistics, right? You learned, but recall. Loudly, please.
I think it's just to get the real value so that it can help you to make decisions about the data or something like that.
Yeah, you are very near, very close to, but there is one question. I want to be more clear.
Just maybe to remove the outliers.
We are not talking about the outlier. Outlier is a different thing. We have some errors, etc., etc. This is not outlier.
We need a mean or baseline
Mhm.
from where we can see or study how much of the different from one point or one reading is.
Yeah, even I can do from the anomaly or departure, but there is a knowledge gap now. There is a one question. Yeah, from the anomaly departure I can see the fluctuation, but there is a question.
Putting the data in the same scale.
Yes, same scale. Okay, you are very close, like tends to 0, but make clear.
To make like trend.
Hmm? That's why I said understanding is the key. Now see the data. Rainfall is in millimeter and this is the degree centigrade. There is two different units.
Yes.
So you can't compare the same labels. Like you want to make correlation now. How? The rainfall is millimeter, like 1 month can be 1200 millimeters, right? And the temperature can be only 26 degrees centigrade. There is a big difference. In data science, it is impossible to make a decision, right? The same like different units. Did you get it? When you normalize, this is the procedure. In the anomaly, there is also the unit. Like you thus removing the influence of the extreme value, isn't it? But there is also the unit. There's we divided by standard deviation. This is now the normalization of the data. When you divide by standard deviation, there will be no unit. The data should be like 0 and 1. Now we can compare the same labels. There is no unit, there will be no unit rainfall, there is no unit in the temperature. That's the data and data. Did you get it? Mm-hmm.
So, well, sometimes we even use the data normalization for single variable, let's say, rainfall or precipitation.
Yeah. Even the same, like,
And we have the same unit, right?
yeah, even there can be, but the idea is the same thing. Some year maybe have like 1200 millimeters, some month there is no rainfall, 0 rainfall. Yeah, you can see the variation from the anomaly, but you can't compare the same labels. That's why we made the standardization, it will be too close.
Isn't it that we just
This is a machine want to check the data pattern, you know the pattern of the data. So when you normalize, it's within 0 and 1, and machine can like understand the data pattern. Then the machine can predict very well, machine can analyze very well, machine can like whatever you say. Like even in machine learning, we normalize the data. That's why machine can understand very well the data pattern, then can predict very well. But if there is a large differences, no, even a human being we can be confused, right? Even the machine is a data science. That's why we normalize. But when is analysis is finished, even in machine learning, we revert the data at the same, the real value. But first we normalize to compare the same labels. Okay.
question?
Mm-hmm.
What's the difference between normalization and standardization of the data?
The same thing.
The same.
The idea is the same. Normalization or the standardization, that's when we are making data 0 to 1. There is no unit. Timer? This is the thing.
Just do one example, like you have a template.
I'm coming. I have the data code here. Yeah, so I'm coming. Okay, so. Okay, there is a question. You can do by yourself. You have the data, you subtract the mean value, then divide by the standard deviation. This is a manual. But in MATLAB, there is built-in function. This is called the Z-score. You don't need to analyze by yourself. Z-score. So Z-score is the normalized. So if you search the Z-score, standardize. Okay, so there is an example. These are real value, then the normalization. Can you see? Also the central, the 0 will be the center, then you can see the how change over time or etc. etc. Easy to understand. So now you just use the Z score. That's it. From the previous data, just I use the Z score to normalize the data, right? Just I want to compare the rainfall and the temperature. I want to do some regression analysis now. We often do regression analysis and we also analyze the correlation coefficient, right? I will not talk too much statistics, but my book is coming, statistics and application in SPSS. So, before I analyze the regression, I hope you have the idea, right? Very basic linear regression. This is our linear regression equation, right? We predict, right? So now, what is X and what is Y and what is A? Who can give an idea with example? It can be, what I said in the first class, we don't care about the fields of study. We care about the mathematics, we care about the data, we care about the statistics. In any case.
So that's why X coefficient X is main and Y is range.
Yeah. What is X and what is Y? Okay, you are the right answer. A is a coefficient, right? Okay. So what is X and what is Y? Give me the real example, a simple real example, so everyone can understand.
So X is domain and Y is range. X is depend upon Y.
X is?
X is depend on Y. No, Y is depend on X.
Exactly.
Sorry.
Yeah.
Y is depend on X.
Okay, I'm giving a value. You just imagine in your field, and you will expel what I say. Like even my statistics class when we started from November is online class. I often say to my students, you need to learn the application. Don't the theory.
Yes.
Don't the theory. Apply the statistics on your field. What is the meaning of X? What is the meaning of Y? What is the coefficient A? What the value? Right? In any software, within a second you will get the results. But what I said in the previous class, when you have the results, you need to interpret. Right? If you can't interpret, it doesn't make sense. So now I'm giving some examples. Say for example, okay, I'm keeping Y, but I got like okay. Okay. This is maybe okay. Happy. It's okay. Just imagine in your field and explain the results. You can set your X, you can set your Y. Now you have the value. What does it mean? Lava. What does it mean? So first we can say what is X and Y. We said X depends, Y depends on X, it's fine. But what is X and what is Y? Yeah. No, this is not exist. We are not talking about exist now. We are not talking about
X depends on Y. Main thing is X, it is an unknown variable. You must know the X variable.
No. We know everything. We know everything. If you don't know how you predict,
What's the question now?
what is X and Y? You should learn from statistics class. It's very basic.
Independent or independent.
Yeah, that's it. X is independent variable and Y is dependent variable. Say for example, X can be a temperature, Y can be a rainfall. Rainfall depends on temperature, but temperature don't depend on the rainfall, isn't it? Independent and dependent variable, right? So now it's clear. Okay, say for example is X is maximum temperature, right? And Y is rainfall. So what is the explanation now? Now we know X, Y, and there is a result. Who can interpret now? Just guess. X, maximum temperature in degree centigrade. Y is rainfall millimeter. So we got this equation by running any software, right? Statistics. So what is the meaning now? Like you have the figure now in your paper, now you need to interpret.
Let's suppose x is equal to 1,
Yeah.
and we have to multiply by 12.5 and plus 30.
Yeah.
So,
Yeah.
then it will be a rainfall, right?
Yeah. So, okay. I'm coming one by one. You're right. First, give me the answer. What is that trend? It is upward or downward?
Upward.
Why?
Because
Positive. The coefficient. Yeah, this is understanding now. If your coefficient, we also call it slope.
slope, yes.
In mathematics, we call the slope. If your slope is negative, that means the downward trend. You should get the downward trend. That means the opposite. If one increase, other thing will decrease. Right? So we got the positive. So if the slope is positive, that means it should be downward trend. If it is negative, it should be upward. And if the negative, then should be downward. First, clear, right? The second, what the brother said, like, if you compare, this is the maximum rainfall. Okay, say for example, if 1 degree centigrade, like if you 1, so 1 multiply 12. So if 12.5 degree centigrade temperature increase, so rainfall, so 1 degree centigrade increase, then rainfall will increase by 12.5 millimeter.
No.
Yeah.
Plus 30.
What? No, C is a consonant.
This is a constant.
This is a consonant. Forget this one. This is a consonant. Forget this one. This is a consonant. So, this is a consonant.
But for example, we should
Yeah,
must have to add.
Add this, but in a like scientific explanation, we often talk about this thing, the trend, and what will like increase or decrease. Like you can add, but this is the basic thing. Yeah, that's correct. So that's the thing.
So can we say that the unit change in y is dependent on like 12.5 times change in x?
What?
Like the change in y, right?
Mhm.
The unit change in y depends on like 12.5 times the value of x.
Yeah,
Is it right?
yeah, depends on it.
So and we don't consider the constant.
No, we don't. Even there is a like equation you can add, but we often consider this one. You see the figures in scientific papers, and you will see we always talk about like was upward trend, like increasing trend we found. But there is now question. I'm coming. There is a p-value, if it is significant or not. I'm coming one by one. Oh.
How can we ignore the constant? It's affect the value.
Yeah, you
How
add,
can we
but
ignore the constant?
you just talk about this thing now. You add or positive, you will get positive or negative. It's up to you. But this is the thing, x and y. Right? Now there is a question in statistics. The primarily we get the upward trend, isn't it? But science community doesn't believe you whether it was upward or downward. Why? We need to test the p-value, Pearson p-value. What is the probability value? Now statistical significant, right? If it is like, I hope you have the idea of statistics. If the 95% confidence levels, then it should be less than 0.05. That is a value. I will not talk much the statistics because there is no time to talk. But in p-value, if it is 95% confidence level, then it should be p-value less than 0.05. If we get this, then we can say, oh, significantly increasing trend. Otherwise, even some of papers, when I submit the first time, said, if there is no significant, remove. We don't care about the insignificant value. Did you get it? Yeah. If it is 99% confidence level, p-value should be less than 0.01. Okay? Now we analyze. Now, that was the regression analysis. We want to make like correlation coefficient. We want to see the correlation between two variables like x and y, right? how was significant, like the positive correlation or negative correlation. Maybe you want to see, right? Then it's called the correlation coefficient, is built-in function. In the square bracket, we can set R and P. That's why I want to know the R, the Pearson correlation coefficient R is 0 to 1, right? Sorry, minus 1 to plus 1. Then we want to see also the P value. Okay? Maybe R will give you like a 0.5. That's mean it's strong, like positive correlation, right? But what was the significance? So that's why we want to print both. So here, X and Y. Normalization temperature X and Y is rainfall. Oh, sorry, let me run again. So this is the R saying 0.57, okay? So it's positive correlation, but 0.05 is not less than 0.05. It still is insignificant, okay? 0.05. By default, it's 95% confidence level. But if you want to change this 99, you need to set by yourself. You will see the example in MATLAB. Okay? By default, it's in every software 95%. Even you can do this thing in Excel. Even in Excel is possible. So this is R and P. Now maybe you want to see the slope. Then M is slope. Is this slope 0.57? That's mean the upward trend. Okay. Oh, this one has finished already. So now we want to plot. And okay, I didn't explain. Look at. Now we want to fit our data. We want to plot the trend, right? We said okay, it was upward or downward, right? But we want to add the trend in our figure. Then in MATLAB, there is different option, like you can use some functions, even you can use like fully fit, etc., etc. But there is another function. It's very easy, just one line. It will give you the trend, okay? So, see here. The function is D trend. Yeah. So data, then use hyphen, then D trend. Then it will give you the trend line. But why I put here the hold on? Any idea? No idea? There is two lines, right? There's the basic, the first one. Then I want to add another one. Maybe I want to add another one. 3 or 4 together. That's why we want to hold on. The basic plot, you will get only one, right? Only one data, right? But also, I want to add another one. That's why I want to plot together temperature, rainfall. That's why you need to hold on. In every software has the function. This is the base figure. Then you want to add something. So you just hold on. Clear? Okay. That's why it's hold on. Then the dtrain function. Yeah, just use dtrain. That's it. The first data, then use hyphen dtrain, then also give the data. First you will plot, then it will give you the trend line. There's a one command, finish. Okay, there is also some statistics, very basic statistics, like if you want to calculate the standard deviation, just type STD, then put your data within bracket, within first parenthesis, right? If you want to calculate the variance, just use the bar. So this is a very basic, okay? Even there is PDF, CDF, there is option. You just type and put the data. Okay, thank you so much.
Actually, yeah, you talked about the temperature and the rainfall. So let's suppose we have a rainfall data here. Suppose we consider temperature data, just the field data. So then we calculate a standardized anomaly. So just
Not anomaly, standardization. We just normalize the data.
yeah, normalization. So normalization. So can we have example?
This is a normalization of data. You can see that temperature rainfall.
So for example, we took any fake data like for example for maximum temperature 200 Fahrenheit and like this. One data set is between 0 to 1. Other data set is 100 and more than 100. So how we can standardize them? First, we have a data.
So we have the real data. In MATLAB, just use the Z score. Z score, the function. It will give you this equation. You have the data, whatever any units, right? You have the data. Then you need to subtract the mean. You can do the mean, right? Then divided by standard deviation, you will also get the standard deviation. That is called the normalization. But you don't need to do by yourself. What I said in the code, Z score, just use Z score, and within parentheses you just put your data. It will give you this normalization data. You see now the data is this, 0 is in the middle. Now you can compare very well. Oh, okay, let me stop the recording.